In this video, let's review algorithm, which is a set of precise instructions for performing computation or for solving a problem. So first thing to note is it's a finite set. So we have a definite number of elements and it's a precise instruction. So there's no room for vagueness with respect to the instructions. Performing a computation for solving a particular problem. So in the end, an algorithm is all about problem solving. Example: describe an algorithm for finding the maximum value in a finite sequence of integers. So how do we go around this problem? We could come up with some instructions written in English, like first off, we could set the temporary maximum equal to the first integer in the sequence. Then afterwards, we are going to compare the next integer in the sequence to the temporary maximum. So if larger, we are going to set the temporary maximum equal to this integer and repeat the previous step if there are more integers in the sequence. Finally, stop when there are no integers left in the sequence. Although it's a bit simple to understand, in expressing the algorithm in terms of this step-by-step English instructions might be vague, because English is inherently a vague language. That's why we also explore the expression of an algorithm in terms of pseudocode, which is a high-level description of an algorithm using structural conventions of programming language. But again, this is not intended for compilation in an actual machine, but this is intended for human reading. Thus, computer programs can be produced in any computer language using the pseudocode description, starting as a starting point. So if we go back to this problem, first we are going to set could be the name. So let's try to implement this, and before implementing this, let's just write the pseudocode. So this involves setting the temporary maximum to the first integer of the sequence. Before this, let's have the name for this algorithm. Say find max algorithm, and it's going to input integer set. Maybe let's just make this a, the integer set, and for the in, so a could be let's just make it an integer sequence, say a sub 1 to a sub n. And the out that we are expecting is the maximum. So this is the heading. I have the input and then the output. So the body of the algorithm is telling us to set the temporary maximum as the first to the first integer. So I could set a temporary max variable to be a1, and compare it to the next integer. If larger, set the temporary max equal to this integer, and then repeat the process. So by repetition, we actually mean a loop. So for I, for example, for the index, by the way, we could have an assignment convention to be the arrow so that it will be less confusing with comparison. So for I, from 1 up to n, or since we already took care of the first element, so we could change this. Instead of 1, we could change this to 2, the second element, because A1 is already the first maximum. So for this, we're going to compare. So compare the next integer to sequence. If larger, set the temporary max equals to this integer. So it's merely comparison, an if statement within this. So you have an if, say a sub I, if the current element is greater than my maximum, my set maximum, then I'm going to update the maximum, update it with a sub I. After that, I'm going to end the if, and finally I'm going to end for. Okay, so this is now a full set of pseudocode. Just remind that this part is the head of the pseudocode. So it contains the name and the input argument, input, output, and the second part here will be its body. Say this part here is the body of this pseudocode or the algorithm. So assign max to a sub 1 for I 2 up to the last element n. We're going to compare if a sub I is greater than max, then update the maximum, and if, and finally end for. So let's code this in our DevC, or it's not a DevC, it's Visual Studio. Let me just call this find max, or yeah, you could just call it like that. It will return an integer, so int find max, and input argument will be I cannot use it's subtraction, so I will make it underscore find max, and let's just accept an integer array, say int a, and this a will contain, say, n, or let's just make it, let's define n. Take note, n is the max size, and this is just a short example, so I will just define this n as maybe 5 elements. So with that taken care of, a sub n, let's implement the algorithm. So assign the first element. Incidentally, if it is an array, so it will start at 0. So I will have an int max and assign the first element, which is a0, to that. After assigning the first element, I'm going to extend a for loop. So for int I equals 1, so it will start at the second element, and while I is less than so So I will just make this less than or equals to n. So since we started at 0, the last index will be n minus 1. After it, we have increment plus I, and one comparison. So let me just put a scope operation. So if a sub I, so if the a sub I is greater than the max, then we're going to assign or update the max to be a sub I. Okay, that's it. So we have now an algorithm. So let's look at it first. You have find max. Input argument is an array. Yeah, so it's a set. We'll do this as an order. Int max a sub 0, the first element. Okay, and then we're comparing the second element until up to the last, and we're going to update the maximum if it is the current element is larger. So one thing left to do is to return the result, return the max. Okay, so as you can see, this is a seamless translation from our pseudocode. So pseudocode, first element max, so first element assigned to max, and then second element, or we loop to the second element up to the last, and we are going to update the max if the current element is greater than the current maximum. The only difference is we started at 0 because in C the first element is 0. And that's it. So let's test this one. Say I have set a 5 elements, so let me just come up with random numbers. So 20, 30, 10, say 1, maybe 90, and 20 or 60. Okay, so with these numbers, it's integer of course and array. Let's print the maximum. So the maximum is the max of given set A is %d. Okay, and let's just call our function here find max, and find max of a set A. Is return an int, and then it's %d. So it's complaining about too few arguments. A is an array, and find max is accepting an array, and int array n. Why is it complaining? Okay, it's because of this space. Anyway, so let's run this one to conclude this demo, and hopefully it works. Okay, build succeeded, and I'm waiting for the output. Takes time. Okay, so the maximum of a given set A is 90, and we have what we expect. Perhaps we could change the given a bit, so let's make this number 100, so it should be 100. Let's run this again just to double check. So where was the, let's stop this run and rebuild. So let me play it once again. Okay, waiting for the run. Okay, so as you can see, the maximum here is 100, and you see that this algorithm works. However, more importantly, we have seen the algorithm which basically translates directly from the given pseudocode. So we have the pseudocode, the given pseudocode. So find max A input output, and we have the body which is assigning the first element to the maximum, and the for loop which updates the maximum when the current element is greater than the current maximum. That's it.